Hello, everybody out there in YouTube world. Paul Hamler here. Welcome back. What we're going to do today is talk about making custom cutters, both for the router and the lathe. And what you're looking at here is a few miniature plow planes. And years ago, I had to come up with a way to make the molding cutters for the fence, the underside of these fences on the plow planes. Some of them were rather complex and rather intricate. And we're going to discuss one of the ways that I used to make these using a socket head cap screw and a saw blade. The little one here in the video right now was a dovetail, a miniature dovetail cutter for inlaying the wear strip on the fence, and also used for making the male dovetails that held the bridge assembly in place on the center wheel plow plane. Each end of that bridge had a male dovetail that went up inside of a female dovetail. Here's a full-size fence that I did with multiple cutters to capture the exact profile of the original. And I think this is looking at now is a miniature third scale for a male patent plow plane. The cutter that we'll be talking about today is these are several examples of ones I've made over the years using a socket head cap screw and brazing a piece of saw blade, 50 thousandths saw blade to the socket head cap screw. These are primarily made to go in a fixed router-based gantry, or you don't typically want to use these free-handed in a router. There's a section of a 50 thousandths saw blade that I cut the blank out for this video. Here's a little different twist. This one, first one here, is made out of a joiner knife, high-speed steel, and then out of a spade bit for this one. And I think that's a piece of 50 thousandths hacksaw blade, and a 1/4 inch and a 1/2 inch traditional high-speed steel tool bit was custom ground for doing a radius profile. A few different examples. There's just a straight cutter that was made out of a flat single lip cutter and another big one that was made out of a spade bit. And the three on the left are commercial available. I call them spoon bits, but they're using reproduction machines in the furniture industry, and they're very easy to grind. This particular one there was used for inlaying the barrel on the miniature Kentucky long rifles. So we're going to start off by throwing a socket head cap screw in the vise, and with the hacksaw, I'm going to line up on the 2 points, 2 corners of the hex, and try the best I can to go down the center of the socket head cap, point to point, and also we're going to hacksaw it and cut it down to the depth of the socket that's in the socket head cap screw. Now these are 1/4 20 socket head cap screws. You could either use ones with shoulders on them. The example we're going to do today was one without a shoulder, but as long as it'll bite and fit in your collet, I've never had a problem with them staying secure. Okay, this guy's cut, and we're going to go over to the bench, and we're going to braze a piece of 50 thousandths saw blade. Top left, that's one that's been finished, and then an extra socket head, and you see where I cut out a section of the saw blade, and I cleaned up just a little bit the slot so that it was exactly perpendicular. And now that the slot in the socket head cap screw has been cleaned up at 50 thousandths, the blade will just fit in there. It should be square and vertical. The only thing that's holding it in is just a little snug fit prior to silver soldering. So I've removed it, and it just goes right back in there. And the socket in the socket head cap screw provides you with an alignment to cut it, but as well it acts as a reservoir to hold the silver solder or braze, if you want to braze it, uh, to the socket head to the blade. In the video, I'm using a micro torch, oxygen, and acetylene. However, as long as you've got a heat sink for your socket head cap screw, you can typically hold them real lightly with a pair of vice grips or some other fixturing device. But you can silver solder with a propane, a propane torch. What I'm doing here is putting flux. It's handy flux. It's a solid flux. Putting it down inside the socket and keep heating it up. And eventually, when the head gets cherry red, the flux will start flowing and it'll be liquid, and it's ready to apply the silver solder. And what I'm trying to do here is get a good even volume of the silver solder on each side of the blade, and it will grip, the silver solder will grip it. So that's a pretty clean well right there, silver solder. As it cools, you'll see the silver solder turn to golden bronze color. I have never had one of these cutters to come out that was silver soldered in. I have broken one in 40 years. I broke one where I got too aggressive. Now here's the blank. Next thing we're going to do is clean it up. But trust me, that blade will not come out of that socket head. It's silver soldered in there. It's a good safe application. And I'll point out these cutters are primarily used for fixtures in the mill or a router that's stationary. You don't typically want to use these freehand and feed them. They're just not made for that. So you need to have an XY table or something to feed your work. So the first operation, we're just knocking off the fire scale here with sandpaper, and then I'm following it with a rubberized abrasive type Cratex type disc. And all I'm trying to do is get rid of the fire scale, clean it up, and make it look presentable like you would the back of a chisel or the back of a plane iron. And also, if you got sloppy with your silver solder and had a big buildup, it'll cut down and level off the silver solder or the brazing. Again, that's a 1/4 socket head cap screw. Using a black magic marker, we're going to put our marker on here to give us a background for scribing the profile. Now, if you've got a real complex profile, you can draw it on the computer, scale it down, and paste it on paper. For this video, what I'm doing here is picking up the center line, and then I'm just going to scribe or score just a general profile on the cutter blank. Typically, what I'm doing these, I'll make up 6 or 8 cutter blanks at one time, so you got a reservoir on them. You don't have to do it, but whatsoever. You can see the profile that are scribed on there, and what we're going to do is we're going to take this thing over to the grinder, and there's a picture of it before I ground. And what I did in the next photograph, you'll see where I remove the bulk of the surplus of the blank, the portions there we go. So I just brought it down close to the line. I never touched the line. So now we're ready to go in with the serrated disc, parting tool, cutoff tool, whatever you want to call it. I start off using the 420, I believe it is, which is the thicker of the 2 Dremel cutoff tools. And if you got any really fine detail, you can go to your thinner Dremel cutoff tool and shape it and score it, form it. but this is it's not a complex profile, but it's just more or less to teach the process and the application. Now, what you got to understand at this point, what I'm doing is grinding on the back of the cutter. And what I mean by that, I'm grinding in because the cutter is cocked about 30 degrees. I am grinding in the relief angle of the cutter. Now, the back side, if you flip it over, will be a sharp edge. So by following the scribe profile with the cutter tilting it like 30 degrees, I'm grinding in the relief angle. Now, these cutters typically I always use them, they're a single-sided cutter. And you'll see later on, I'll go in and there's a couple of ways to do it, but basically you want to remove the stock on the opposite side of the blade so that only one edge is cutting in the back. The other opposite edge is not touching the stock at all. Using an India stone to start with, I'm just going in and knocking off any burrs that was formed. Then going to lap it with a fine diamond lap. All we're trying to do here is make sure that cutting edge profile is flat and crisp and sharp. And then I follow it with a hard arcing saw. And it doesn't take a lot because the Dremel tool, as it's cutting the profile and sculpting the profile in the back, leaves a pretty crisp edge. Now you can go in there and with small files or small stones or whatever, and detail it to your heart's content. But these things cut pretty clean, just with what little bit of cleanup I had. I've got a piece of stock mounted in the mill here, and you notice the black line, the black pencil line was where I wanted the cutter profile to pick up. And anything from to the right of that profile line or that cutter line, I just went in with a hand plane and chamfered off to remove the excess stock. I said, well, just get as much of the stock away as you want and let the cutter, cut its profile. So otherwise, I would have had to feed the work into the cutter in increments to get to the point that I'm at right now. But by hand planing, I was able to eliminate that, slow inward infill or infeed. And you see the sharp angle taper on the left side, that was ground away. It's one way of doing it. The other way is, like I said, with a pair of calipers, you could lay it out and just make sure you can rough out the same profile as your cutting edge, but there's not a lot of mass and weight in these 50 thousandths saw blades, so it's not really a balance problem. These are just a few shots of some I've done over the years. Most all of these I did the process where I balanced it, but there's only one edge of that cutter is cutting, and the rest of it's been ground away. So anyway, that pretty much wraps it up. If you have any questions, give us some comments and some feedback, and we'll see you next time. Bye.